What's going on, everyone? In today's video, we're going to look at a word problem involving quadratics, and we're going to see how what we've learned before can be applied to what might look like a more complicated and multi-step problem. We'll find that it's really just as easy as following the steps that we went through before. Let's get into it. All right, so our prompt is very basic. We have a rectangular mirror that has a perimeter of 260 centimeters. So let's find the length of the mirror in the length of the mirror is x centimeters. Let's find the height in terms of x. So again, we're given that length right here is x, which means that on our top, we're going to have x centimeters. And then what about our height? Well, since, let's say x is horizontal, let's say that y is vertical, so let's call this y centimeters. Okay, so what that's going to mean is that, well, if we look at the perimeter, what is that? That's going to be x plus y plus x plus y. And another way to write that is going to be 2x plus 2y is going to be equal to 260. So if I wanted to factor out that 2 or divide each side by 2, I could end up simplifying this to x plus y equals 130. And then I want this to be I want this equation in terms of x. So I'll have y is equal to 130 minus x, and that is going to be my equation. So now let's find an equation for the area of the mirror, a centimeter squared, in terms of x. So the area is, of course, going to be length times width, which in this case is just going to be x times y, or length times height, whatever, your two dimensions squared. But I have an equation here for y in terms of x. So if I plug this in down to here, I'll now have this in terms of one variable. So x, there we go, a would be equal to x. Let me plug in y for x. Let me plug in x for y. My apologies. It's very easy to get tongue twisted on this. But I'm plugging in my value for y in here, because that's right here. So now I have only this equation in terms of x, much easier to solve and graph. So now we want to plot a graph of this equation for the area of the mirror with a on the y-axis and x being the length on the x-axis. And that's exactly what this gives me. A is going to be my output, x is going to be my input, which is the length. So as long as I graph this, I'll be fine. So in our class, we're allowed to use graphing calculators with AISL. And so what this would mean is that we would graph it here, we would find our zeros, and we could also find our maximum value up here. So it should look something like this. You'll have 130x minus x squared. You'll have a 0 at 0, 0, and 130, 0, as well as a maximum value, a vertex of 65, 4,225. So now the prompt is asking us, so the question asked us, what do these two zeros mean? What do these two x-intercepts mean, 0, 0, and 130, 0? Well, keep in mind what the problem is asking us. X is going to be our length. Our y-coordinate is going to be our area. So if you think about this, look at what the y value is. In 0, 0, it's 0. Oops. And in 130, 0, it's 0. So what this means is that this is going to be the value of the length that gives us a area of 0. Yeah, so what this means is that if you have a value of 0, 0 or 130, 0, let's take that into context. X is going to be my input for the length, and my y is going to be my output for area. So if I have a value of 0 for my y, that means I have no area. What this means is that these are the lengths of the minimum and maximum values that will basically give me a mirror in the first place. If I can't go anything less than 0, I can't go anything greater than 130, including 130, including 0. Because that gives me an area of 0, which means my object doesn't really exist in this case because it's a mirror. I need an actual... I need two dimensions in order to see myself in the reflection. So I have 0, 0, 130, 0. So that means at 0, with a length of 0 and a length of 130, that is what I have to operate in between. Those are the values of the length that I have to take into consideration when I'm thinking about minimum and maximum length values. So let's find the equation of the graph's line of symmetry. Now, there's two ways to do this. You can use your negative b over 2a. That's a very standard formula. But one that we went over in class is that you can actually find the average of the x-intercepts. What that's going to do is, if you think about it, the vertex, whether it's a minimum or a maximum, is going to lie right in between the two x-intercepts. And that's exactly what the line of symmetry does. It gives us the x value of the vertex, but it's also this up and down vertical line that splits this graph into two mirror images. So if I want to figure out what the line of symmetry is, I already know from the previous problem what my x-intercepts are, which makes this quite easy. X would just be equal to 0 plus 130 over 2. So 130 over 2 is going to give me a value of 65. So at the value of x equals 65, it is going to cut this graph in half. So state what the equation of line of symmetry tells you in this context. So let's actually graph this and take a look. Looking at the graph, I went ahead and graphed the axis of symmetry at x equals 65. So you can see that it splits this perfectly in half. And so what this is telling us is look where it kind of intersects this, our parabola. It's at 65, 4,225. And notice how x equals 65, the midpoint between the two, the axis of symmetry, is also the x-coordinate of the vertex as we previously stated. But look at what it is. It is the vertex. It is the maximum value. It is the maximum height of this parabola. And what is the height in this case? Area. So what is 65? That is the length for x that is going to give us the maximum possible area. Because you can just look at this graph. When I have 65, it's going to be at the very tippy top of this peak. It's going to be at the vertex. And what is the y value, the output, the area at x equals 65? 4,225. So that's exactly what it is. So I hope this really helped. We use our graphing calculator quite heavily, which we're allowed to do in our class, at least in IB AISL. If not, there are multiple ways to do this by hand. Again, use your calculator to your advantage. Find your x-intercepts, find your vertex, and use that to solve the problem in the context of the question. All right, hope that helps, and I'll see you all in the next video. Take care.